My name is Eugene, and let's continue our discussion on gravity. So in a previous video, I discussed my vision of creating a device, or more specifically an anti-gravity device. So the ability to lift off the flow of gravity particles, um, and then have this device be used either for terrestrial transportation or for interstellar transportation. But before we can discuss this device or anti-gravity or gravity in general, let's first discuss what is my model, or my model in terms of reality. What is my understanding of how reality works? I believe by having a clear model of reality, we can forge a path towards creating such an anti-gravity device. So my understanding of reality, I'm leaning more towards the idea that our reality is more of a simulation. So essentially, our reality, what you see around you, is rendered in a certain way. And I also believe that there's a rendering aspect, and there's an aspect of controlling, what comes next in terms of the rendering. So I would like you to imagine a bubble. And in this bubble, you essentially have, it's essentially a void bubble. There's absolutely nothing contained in that bubble. So there's no gravity particles, there's no electromagnetic particles, absolutely nothing. So it's a 100% void with no particles at all. So I'd like you to imagine having a single particle within this void. And this particle, let's say it's some aspect of a quark. So this is, typically, or we've come to know that if you break matter down, you break them down into atoms, and you can also break the atom down into further into protons and neutrons and electrons. And we've discovered also that you can break electrons, or the subatomic particles, as they're called. You can also break those further down into virtual particles, or quarks. So even the subatomic particles are made out of more particles, and those particles are made of more particles. So the more they break, or attempt to break these particles apart, they discover more and more particles. So imagine this particle is one of those tiny, tiny building blocks of your subatomic particles. And also imagine, because this is a void, there's nothing that can impede the speed of this particle. So another assumption then is that this particle is in motion. And because there's nothing that can affect its speed or its velocity, it can it can travel at infinite velocity. So that means that if we could observe this particle could exist in multiple positions because of the fact that it has infinite velocity. So if you could imagine that, right? If we if we could take a snapshot of this bubble at 1 second intervals, and and imagine this bubble is of reasonable size, right? It's big. So, but because this particle has infinite velocity, even if we look at take a snapshot that has a 1 second exposure, this particle would essentially be observed, or this bubble would be observed as a solid blob, because what we are seeing, we are observing the particle in every single position within this bubble. Now let's have that time, right? We'll probably still see the same blob. It just becomes less solid. So the more we um, narrow down in terms of our exposure, if we make those exposures really small, maybe 1 billionth of a second, even smaller, we'll observe that we'll, instead of seeing a blob now, we'll see more details within this blob. And that is just because our exposures is so short. We can observe the particles, or we can observe more of this particle. So what we are observing here is, every time a particle crosses several times in the same position, we're essentially observing that spot. So my belief is that this is the way our reality is rendered, where depending on what frequency we observe this bubble, that determines what detail we observe in this bubble. Another aspect of this is that each of these, so if we look at this bubble at a certain frequency, let's say frequency x, then that would represent a certain snapshot of that bubble. So, and also this particle is most likely, it's so this bubble essentially would represent a resonant cavity. So this bubble then, or this particle would, it would appear random, but since it's resonating within this bubble, its location could be predictable at some points in time. So that means at a certain frequency, we'll observe certain structures. So if we observe frequency x and then observe frequency x2, the structure that we observe will be different. But if we switch back to frequency x, we'll observe the exact same structure. So essentially, so our reality then is built out of these what I term them as frames. So if we look at continuity within reality, continuity is essentially a sequence of these frames. So going from one moment to the next represent a series of these frames. So that means every time every time there's motion, or there's continuity, or every time time flows, we essentially switch through a series of frequencies. So we never switch back to the same frequency. We always continuously change what frequency we observe this bubble in. So therefore, a timeline then represents a series of frequencies. So essentially, then reality is then built, similar to how we have in movies right? A movie is a sequence of moving frames. So that's exactly, how this model of reality would work, where this single particle, renders everything we see around us, but we only observe a certain state of this, of the route this particle traverses within this bubble, by essentially just looking at different frequencies. So this is something we'll attempt to prove later on in the series. And the way we would attempt to prove it, we can either build a physical device where we have some sort of resonant cavity and we have a particle bouncing around in it, and then maybe we'll have a strobe light, or you can probably just imagine it as well. We'll have a strobe light at a certain frequency. So if we have the strobe at a certain frequency, we'll essentially observe the particle, or the particle that's bouncing around in that resonant cavity would then exhibit certain structures. Different frequencies represents different structures of this of the motion of that particle. And then we'll attempt to to build frames, and then we can attempt to also show that we can build a continuous sequence of these frames, and something that makes sense. Maybe we'll have the some sort of structure move across the frame. So that would certainly give credence to this model. So how does that relate to gravity? So gravity then would represent some sort of rules in terms of how this model is applied. So if we just had a series of these frames, they would not make any sense, right? Because there has to be something that filters these frames out into a series of frames that make sense. So along with this model, there should be some sort of control mechanism that orders these frames into something that makes sense, right? So if I have continuity, right, if I walk, I don't want to suddenly end up in a different spot. So there has to be some sort of filtering mechanism that give us a reality that makes sense. Now, I can, of course, teleport to a different position by simply somehow switching my frequency to match a frame that represents that frequency. And later on we get into teleportation, because this model would also allow for teleportation. And teleportation would essentially just being the concept where an object matches a frequency of a certain frame. But we'll get into that later. So how does that relate to gravity? We have this control mechanism that applies certain rules on these frames, and then it produces it filters out these frames to produce something that adhere to some sort of reality. So there could be different realities depending on the filtering mechanism. So in our reality, we have gravity, and gravity makes us stick to our planet. So this filtering mechanism then filters out all the frames that represent a reality where we have gravity. So the next step for us then is to determine how we can use this model to model gravity. That's it.